A'udzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Salam sejahtera to everyone. Can you hear me, class? So how do you find the quality of sound? Is it clear?
Clear, doctor.
Okay, thank you. First, I would like to say sorry because I got sore throat, so my voice might not be very clear. So you found that something that you don't understand about what I'm talking about, could you please, say so that I can repeat couple of times, yeah? So that is one thing. The other thing is, I do find that due to the, what do you call it? Um, due to the printing, technical error, some of the printing data, yeah, in your notes or in your book is inadequate. So I will help you to do some correction, and please bring along your books. It's only a small correction. I did find when one of my colleagues just remind me that I take the old version to print rather than the new version. So I'm sorry about that. So before we start the lecture today, as I mentioned earlier, so this is the third topics. The third subtopic regarding the gear system, which will be on the last topic of the gear system before we meet another topic, what we call as balancing. Yeah? The first topic is talking about the hoist, some called lifting machine. Then we are talking about earlier. Yesterday was about vehicle dynamic, which is not very difficult. Only a short 2 hours lecture. And this one is more challenging compared to vehicle dynamic and also hoist. And I be rather frankly say that the applied circuit gear is most likely to be your test question, or perhaps in your exam question or exam topic or test topic, due to the what they call it. It's not due to the difficulties now. It is due to the widely used in engineering world or in engineering perspective, talking about the gearing system or gear system. Okay, so please be focus in this topic. It is not very difficult topics. Yeah. Okay. We'll start with as usual. We start with this one. This is what. Okay. Sorry. I only share with you this. The sorry. Yeah. I supposed to share with you with PowerPoint. Okay. So this is a GP cycle gear. If you remember in my discussion earlier, yeah, we have what? Okay, we have one will be the simple gear. Then we have compound gear. Then we have riveted gear. We haven't talked about riveted gear because these three gears, talking about the compound gear, simple train, compound gear train, also riveted gear, is part of the compound gear train. And last but not least,
Sorry, I can't see the screen.
Sorry, can you hear me?
Can, doctor, can hear.
So anyone could not hear me? Speak up, please. I put my volume at maximum now. It's 100%. So I have no idea why if you can't reach my voice. Can you reach my voice? Yes, thank you. Thank you, Rafi. Okay, thank you, Ahmad Hafiz. Okay, again, yeah, talking about the gear train earlier, we have simple train, compound gear train, then we have riveted gear train, and also epicyclic gear train. And I did mention about the compound gear train is basically consisting of the riveted gear train and also epicyclic gear train. And the riveted gear is a part of epicyclic gear train. So whatever you learned earlier, talking about the gear ratios and so forth, is basically been used again and again in these topics. The only difference now is we are now dealing with vectors. It simply means that we are talking about direction. The previous one, we don't know whether the direction is positive, negative, clockwise or counterclockwise. Now we are going to define whether the direction is clockwise or counterclockwise. Yeah. And with the notation for clockwise as usual is positive and the counterclockwise is negative. That's in the standard notation or standard sign. Okay. And The epicyclic gear, this is the use of epicyclic gear. This is the epicyclic gear. This one is the you know what you call it, the cross-section of epicyclic gear. It is schematic diagram. In fact, it's not the actual one. This one, yeah, used in turbine or the epicyclic. Typically, if you have vehicles four-wheel drive, for example, yeah, it's also used for in the epicyclic gear. Okay, so I'm going to talk about what is the epicyclic gear. Okay, so the epicyclic gear comprising of, as I mentioned earlier, remember you have four components. One will be sun. Sun is the inner gear or the inner wing. The next one will be the next one will be the outer wing, what we call as annulus. And then you have planetary to connect sun and annulus. And to hold the planetary so that the planetary will not you know, run or you know freely rotating, hit again, you know to each other. So it is hold by another link we call an arm. An arm is not a gear, but it's basically a link to a system to hold the planetary. So in conclusion, anything you did find that whole arm, sorry, whole planet call an arm. Okay, so it will be simplified as this one. Huh? This one I mentioned earlier. Look at here. This is the annulus. Can you see my mouse here or my pointer? Can you see my pointer? The annulus, the 8 outer gear. This one is the planet. You have 4 planet and 5 planet, doesn't matter. Yeah, is this a planet? The what you call the role of the planet is basically to connect between the annulus and sun. Sun with the inner gear. Then to hold this planet, the 4 planets, so that the planet will not hit each other, we have the green one here, what we call as an arm. So these 4 component of you know body in a gear or in a one gear, we call it the epicyclic gear. Okay, so if the question asking you about what do you understand by epicyclic gear, so first is defining what are the 4 components. Then defining the other thing is what there are 2 connection. One will be the internal connection, the other one the external connection. I'll be seeing you what I'll be talking about like internal and external connection later on. Yeah. So after you define the planet, annulus, sun, and arm, then you define the connection. So this is the connection. Look at the connection. Okay, the connection is simply, look at here, this one. Okay, I'm going to share with you, look at very carefully, yeah? I'm going to share with you, I'm not going to share with you because I can't write anything on that. So I'm going to share with you the PowerPoint, sorry, the PDF so that I can write something on the screen, yeah? This one, isn't it? Okay, look at here. So I'm going to write something on the screen. Look at them. This is the annulus. Oh, excuse me. This is the annulus. Annulus. This one is planet, isn't it? You can put P1, P2, P3, doesn't matter. This one is sun. And you have another one, remember? This one connected or whole. These 3 we call an arm. This one is annulus. This one L. L is arm. L for stand for arm. Okay, so if you look at very carefully, class, if I can, you know, if I can clear this drawing here, you have this one within the annulus and planet. This one be internal connection, internal connection. So what is the internal connection as what we learned earlier in our class, in our lecture previously? So what is the internal connection? So the internal connection, you found that both gear, yeah, A and P, for example, and that's planet, same direction. So meaning that same direction. If supposing this one running clockwise from your seat, this one also running or rotating clockwise, and these 2 called positive direction. If they are rotating the other direction, the other direction meaning that counterclockwise, Counterclockwise is still analyze here. This one is also planet. Counterclockwise. So this one is counterclockwise, isn't it? So this one is negative. This one is negative, correct? Same. Okay, same. Okay, the other one is positive, positive, negative, negative. The other one from the planet to sun here, this one is what we call external connection. So the external connection where you found that two gear meet together, rotating together, or perhaps connected together, but rotating what? Rotating different direction. So if this one rotating counterclockwise, this one will be rotating clockwise. So if you noted this one as negative, this one will be notified as positive. Understand me or not? So to understand that, I would like to share with you the animation so that you can easily understand what is the meaning of internal and also external connection, talking about epicyclic gear. Get this one very careful, class. Okay, yeah. This one is what? Rotating counterclockwise, rotating counterclockwise. This one rotating clockwise, as what we discussed earlier. Isn't it the same thing here? So all the internal connections seem that rotating same direction. All the external connection will be rotating different direction. So that you have to understand, yeah. Okay. Any question up to that? Any question? Anyone? No. Yeah. Okay. Thank you.
Clear, doctor. Clear, doctor.
Okay. Next, they were to define to do the what they call it, yeah, to calculate the gear ratio, because our aim is two things. You have two aims or two tasks or two target. One will be we want to calculate what if the gear ratio of the epicyclic gear. Okay, the other one we want to define is what is the torque generated by the input or output, or generated by the system to hold the gear, or perhaps the power transmission from the input or output. So that is what we call as kinetic and also kinematic. The first part we are talking about kinematics. Okay, kinematic meaning that we're talking all the rotation purposes. To help you understand about how this episode run, yeah, I'm going to share with you a video here. So if you can't hear anything, so you just say to me so that I can do something about that. Huh? Hold on. I'm on my. Hold on. You don't hear anything yet. I'm going to share with you the video now.
Basic planetary gear set has a sun gear,
Do you get the
which
video?
meshes with
Do you get the video now?
most automatic transmissions.
Yes or no?
Yes, doctor.
Most
Do you
automatic transmissions use epicyclic or planetary
the
gears.
sound?
They are
Can doctor
common
can
as
hear?
such other
Yeah.
use epicyclic or planetary.
Yes or no?
Can doctor?
Okay,
Can.
now, okay, I'm going to repeat, yeah. So you please listen up very careful. I'm going to put the volume at the uppermost so that you can hear very careful. So this is very important to understand, how to go about it. Yeah. Okay, now I'm going to start all over again. Okay, class.
Most automatic transmissions use epicyclic or planetary gears.
So it mentioned about most automatic transmission use epicyclic gear, isn't it? So there is one thing. So if the question asks you in the exam, where will be the epicyclic being used, the automatic transmission? So that will be the answer here. Excuse me.
They are constantly in mesh with each other. A basic planetary gear set has a sun gear, which meshes with planet gears, also called planet pinions. The planet pinions, in sets of 3 or more, rotate on bearings, on hardened steel pins on a planet carrier, which spaces the pinions equally around the sun gear. It also locates them so they can mesh with an internally toothed ring gear.
So it does mention here all the component as I mentioned earlier, but the most important thing is the whole component are constantly connected, It will not be disengaged, yeah? It's always connected. And so that's the beauty thing of the episode gear, because it's always connected from one gear to another gear. Okay.
This means the planet pinions are always in mesh with the sun gear and the ring gear. In operation, their motion is described as either walking or idling.
So walking idling is what does it mean? When all the connecting gear of the sun to what the planetary is rotating. So you call it walking or idling. Yeah? So in exam, perhaps we're talking walking, yeah, or idling. You know that what it is walking or idling means, yeah.
Walking means that if either the sun gear or the ring gear is held stationary, the alternate driving member rotates the planet gears on their pins. This turns the planet carrier in the same direction as the driving member. Planet gears always turn in the same direction on their pins as planet carrier rotation, while they walk around a stationary sun gear. They always turn in the opposite direction on their pins while walking inside a stationary ring gear. Idling refers to the rotation.
So walking mean what? One gear should be held. So that is walking. Idling mean the whole gear will be running or rotating independently.
Of the planet gears on their pins whenever the planet carrier is stationary. Torque is transmitted from the sun gear to the ring gear, or from the ring gear to the sun gear.
Remember, torque is transmitted from the sun gear to ring gear or vice versa, from the ring gear to sun gear. So it doesn't matter. Sometimes sun can be input, some can also be output. So we have to understand that, yeah?
Via the planet gears and the stationary carrier. In both cases, the driven member is turned in the opposite direction to the driving member. To provide the ratios available from the gear set, one or more of the components must be held.
Just listen up very careful. To define the gear ratio of the whole set, one or more component to be held or to be locked or to be whole, yeah? So by what? This one.
Or released.
So you have two type. One, you have to release the gear. Release means the whole gear will be running. The other one, you have to lock the gear. Which gear? The question will tell you. Lock gear A, for example. Lock gear S, for example. So you have two definition to define what will be the gear ratio. Remember that, yeah?
This is normally done by hydraulic servos, operated by transmission fluid under pressure, acting on lined bands or clutches, or by one-way clutches. They allow turning in one direction, but act as a lockup or reaction member in the opposite direction. In practice, a combination of these is normally used.
Okay, that's about it. I'm going to close this one. I'm going to share with you another one here. So I'm going to say something about what sorry, I'm going to I'm going to stop here. I'm going to share with you another file, the animation. So from the conclusion, what been elaborate from the the clip video just now, yeah, to define the epicyclic gear ratio, two two condition must be satisfied. One of them, you lock the gear, or you free the gear. So who decide? You have to you have to read the equation very careful. If the equation basically asks you to lock any part of the gear, you have to follow the instruction of the equation. If the equation doesn't mention about locking any part of the gear, you cannot lock in the gear. Okay, so if you look at it very careful, the first stop, this one, all gear are rotating, isn't it? The other one will be, the end has been locked, but the other gear are basically rotating. Can you hear me, class? Yes or no? Hello? Okay, thank you. Okay,
Ask
thank
you.
you, John.
I want to ask.
Okay. Yes, please.
The first figure, the previous slide, why the gear rotate or same direction?
Which one? Are you talking about this one?
Yeah, no, just now. The
Yeah.
two figure. Yes, yeah.
Okay, this one is only animation, yeah, animation
Oh,
only. This one only animation to show you that one you can free the gear. This one is free one, whole gear can rotate. The other one you have to lock the gear. Which gear you lock is the analyst gear you lock, or perhaps you can lock a planet, or perhaps you can lock the sun. Any gear connected to planet you can be locked. Okay, this one is only to animation to tell you that two methods to find gear ratio. One is to let the gear running freely. The other one is to lock any part of the gear connected to planet. How do you know? It's basically mentioned in the problems. Okay, this is not the actual thing. The actual thing is this one. This is the actual things. Huh? Look at there. This one is all gear running freely. Huh? Okay, we will start from the simple gear first. Okay, simple gear first. This is the simple and compound. This one is the simple one. This is the actual one. Simple but actual gear. It's a gear. So many components here. You have the spring, you have the pin, so on and so forth. Isn't it? Here it's the same thing. This one is compound. Yeah, you have one train, two train, three train here. In fact, four train here because you have A4. So this is the four train. The most I think it's not very difficult, but the most challenging train if you have this one in your tutorial or test, whatever sort is it, yeah. So just look at the analyst, sun, wheel, and planetary, and also arm. That will tell you how many train you have. For example, this one simple train will consist one arm, isn't it? Analyst and sun. Planet doesn't matter. Sometimes this one like this one, yeah, this is a simple train, but you have what? Three planet. So you have one analyst, one sun, and also one arm. What is the arm? Arm is anything that hold the planet. Okay. Very messy, yeah. So many component. We will try to get rid of all the component that we do not know, we do not want in calculating the gear ratio. So what you have to do now is basically we are going to simplify to become this one, which is very simple, isn't it? You have only analyst, you have planet, you have sun, and any any link or any body that connect or carry planet we consider as an arm. Okay, this shaft could be input or perhaps could be output. This one could be input or otherwise. Yeah. Um, okay, so this is another one. This is the compound. Do you get the second slide? Plus, do you have my second slide?
Yes,
Repeat.
Doctor.
Okay,
Yes,
if you don't, if you can't, if you can't receive very, or perhaps it's very slow, yeah, lagging time, you can check on your note because I also provide your note this morning, yeah. So this one, what we call is compound gate train. The compound gate train comprising what? One analyst, two analysts, one sun, two sun, and you have two arm, L1 and L2, and you have input and also output. Okay, the other one same thing. You have S1, S2, A1, A2. You have O1, you have O2, you have K, and you have I. But remember this. Remember this, yeah. Anything which is not anything that connected to analyst or connected to connected to what do you call it, yeah, internal gear. Later on you found it so connecting to sun, yeah, will not be considered as epicyclic gear. So the last gear of the epicyclic gear is basically analyst. You understand me now? So the last gear of the epicycle is basically analyst. So if I can share with you this one, yeah, I'm going to stop sharing this one. I'm going to share with you the PowerPoint so I can write something on it. This one, yeah. I need you to understand this one before we go further. So this one, so look at here. Look at here. So this is the compound gate train. So the compound gate train, what I mentioned just now, you have one S1, S2, you have A1, A2. You have what? L1, this one is the L1, L1. How do you know L1? Because it's carry P1, L1. This is the L2. How do you know L2? Because it carry P2. This is L2. Okay. So you have this one is compound a train noun. Any gear connected to annulus, this one will not consider as epicyclic gear. So this one will not part of the epicyclic gear. But you need to do the calculation, but the calculation will not be done in the in the what do you call it, in the compound of the epicyclic gear. Okay, same thing like this one. You have S1, S2, correct? S1, S2. You have A1, you have A2, correct? This one is O and this one is L1. This one is L2 because it carry P2 here. This one is L2. So this one is not part of epicyclic gear. And this one, in fact, is not part of epicyclic gear. So the last gear will be annulus, expanding radially. The inner gear will be sun. So anything that connected to A1 will not be considered as epicyclic gear. Okay. This one is more challenging because you have three components. Sorry, three train here. You have A1, this one A1, A2, and A3. For example, you have L1, L2. This one is for L3. So this is more challenging. Yeah? We are going to do this one later on after we completed the easy parts. Huh? And this is the actual thing, which is very tedious, isn't it? Very messy. Drawing. So we will simplify as in this form. Huh? Okay. Any question up to that? Any question before we proceed to the next one? No? Okay, now. So as I mentioned earlier, beside having all the four components just now, the sun, then you the annulus, then you have the planet, then you have the arm just now. Beside having this one, isn't it? You also need to know the motion, which is external, and the internal meshing occurring on the system or on the gear. Okay, where you found that the sun and the planet is always connected externally, and the planet, the annulus and planet will be internally connecting, which will give you internal connection, also external connection. So I'm going to share you again because I want you to understand this one. I'm going to stop sharing this one. Sorry for this one. Yeah, I'm going to have the animation a bit so that we can here. This is all the external connection as what we did earlier, isn't it? So no big deal. This one, remember, this one, the internal connection and external connection comprising in the epicyclic gear. This one, yeah, in epicyclic gear. So how sure are we the internal connection is talking about this chain and sprocket here? You found that both body will be running or rotating same directions. So the gear ratio equation used as previous, but we're going to change the notation from 2 to become A to become S to become P, because there is no 1 and 2 here. We are talking about annulus, planet, and sun. But the basic principle talking about input and output for the kinematic, also geometric, is the same. Okay. Okay, so any problem before we move on, class? So the animation, we complete the animation. So I'm going to focus now on calculation. I'm going to focus on calculation, this one. This one, remember, look at the class. This is very important. This is the principle before we move on. Yeah, look at here. For supposing you have gear A and B, yeah, and we found that this N will be the gear ratio. The gear ratio is always output and input. So it simply means that is the output. This one is the input. So NO by N, NO by N, NO by NI. So NO will be NB by NA. And we inverse this one because this one is, remember, kinematics. This one is geometrics. And we have negative sign here. Why negative sign? Because it's basically rotating different direction. Okay, because rotating different direction. So if you have 3 gear, which is already done here. So just focus this one. Okay, this is what we done in a gear system earlier. But for the epicyclic gear, this is the epicyclic gear. I'm going to explain this one very detailed. So let me share with you my working template here, so that I'm going to write something. So I'm going to explain about the gear ratio basically. So you have this one. Okay, yeah. So we haven't do the solution yet. We are going to look for the gear ratio first. How to define the gear ratio. Later on, we are going to use the solution, meaning to say that we're going to use two methods. One will be by looking at the tabulation method. The other one is by using what you call it as relative velocity, as what you've done in dynamics. Or some call as the analytical analysis. So look at this. Supposing you have that A is the input. A is one. I put it here, A as the input. A is the input and S the outputs. So A is the input here. S will be the outputs. So remember the gear ratio is always what? Is omega O. Earlier we studied it by omega I. But there's no omega, we can put N here. And this one NO by NI. You don't want to put NO and I because we have only A and OS here. So you put here NS by N by NA. Right? So first you need to define what will be the S and A. So from chain rule equation, study in mathematics, we have N, oh sorry, you have NS by NA is equal to, if you focusing on these two gear, even if you have, and right, you're focusing on these two gear only, sorry, focusing three gear, you have A, P, and S, then you check on, perhaps you start with, perhaps you can start with, what do you call it? You can start with gear ratio between this one, yeah, this one is the input, this one is the output, right? Between the A and P, endless and planet is equal to, you will have NP by NA. Correct, not? Is equal to TA by TP, isn't it? But remember, when we are doing this one, you know that these two are running or rotating in the same direction. We have plus here, right? Then you go, then look for the gear ratio now between the planet and sun is equal to, we have N sun by N planet equal to the T planet by T sun, correct? Isn't it? But remember, so sun and planet is always rotating, sorry, is always connecting by the external connection. So it simply means you have a negative here. You understand me or not, class? So the gear ratio overall, yeah, or perhaps you can say that the gear ratio between the annulus and sun is equal to the gear ratio of A by planet multiplied by the gear ratio of planet by sun. If you pick up one of the ratio, for example, so we are saying here, you are getting NP by NA multiplied by NS by NP, isn't it? Or can also be written as, you have TA by TP multiplied by TP by TS. But remember, we have negative here, so I put the negative here as weight, yeah, so that you can easily differentiate. So you have negative here. So if you can cancel this one, you cancel this one, which will bring back to the original, equation, NS by NA. So it becoming here, this one can also be cancelled off because it's common factor. So you found that become negative TA by TS. This one is NA by N and S by N. T equal to N. You understand or not? Understand or not, class?
Doctor, I have a question.
Sorry?
I have a question.
Yes.
How can you determine which one is the input or output? Let's
You
say
can
if the S and P in the planet, which one is the input and which one is the output?
So this one is the A, yeah? First A to P. So this one is input, this one be the output, correct?
Yes.
Then when you're talking about P and this one is input, this one become output, correct?
Yes.
I
Alright.
think I explained to you in my first lecture. If you three gear, for example, gear number 1, gear number 2, gear number 3. This one is basically input. This one is basically output. But if to do the gear ratio, first you break this one in two pieces. Then you found that this one is input, this one is output, isn't it?
Yes. Yes.
Then if you look
Right.
at 2 and 3, now it become input. This one
Yeah.
become outputs.
Alright.
Okay,
Thank you,
this is
Doctor.
exactly as what we done earlier. The difference now is there is no notation 1 and 2, no longer notation 1, 2, but in fact will be in terms of A, P, and also S. Okay, so just remember that the gear ratio between S and A is always negative here. So, but you need to check and also prove whether it's correct or not. How to check and prove? Okay, now this is by analyticals, but to prove it is by what? By looking. To prove it, you want to prove by refer to figure. Analytical say the negative. Want to prove correct or not? Okay, now we go back to here. You go back to here. Now, it's not very careful here. So if A is rotating clockwise here, isn't it? So from your seat is clockwise. This one is positive, as I mentioned earlier. So this P1 is also rotating positive because these two are internal conduction. You have positive, correct? Isn't it? So when the P1 are connected to S, and this is no longer internal connection but become external connection, this one become negative, correct? Huh? So finally, from A to S is always what? Opposite direction. So it always opposite direction. Understand or not? Yes or no? So it doesn't matter, yeah. It doesn't matter. If you have, for example, a gear, but then it is rotating the other direction, it doesn't matter. As long as you can understand how does it works, yeah. So supposing this one is analyst, this one is sun, this one is planet, this one rotating what? Counterclockwise from your seat. Let's say this one input, yeah. So this one rotating counterclockwise, this one also rotating counterclockwise, and I put it as negative. I put it as negative. Because why negative and negative? Because internal connection. And as planet and sun meet or connected, this one is the external connection. From negative to become positive. So again, if you compare these two, it's always rotating negative direction. So N, the overall gear ratio from NS to NP, for example, NS by N equal to TA by TS, you have negative here. You understand me? You understand me now, class? That is very important because this is the what you call it, the principle of the gear ratio before we meet the other parts of the gear huh? The other part of the gear. Okay. Any question? So we study only today this one. Very important. A and S is always running. Running one. Always running one.
Different direction.
Opposite direction. Always running opposite direction. Okay, now another thing that, or another equation that you have to know is talking about this equation. You have the equation as for the riveted gear. If you remember, riveted gear, you have R1 plus R2 equal to R3 plus R4. When you found that the internal gear, when you found the when you found the input gear and the output gear, in the same shaft, for example, yeah, this is what we call as riveted gear. So if this one gear number 1, gear number 2, gear number 3, gear number 4, so you have this one, correct? And it is very logic because this distance is equal to that distance, correct? And you know that the pitch must be equal for both 1, 2, and so 4 and 3. So finally, we have T1 plus T2 is equal to T3 plus T4. So here is the same thing, but the difference now here, if you put this one, yeah, the input and the output now is in one shaft, so it is becoming a reverted gear again. And when you found that from the the shaft here, the internal shaft, from to the outside gear, the last gear, you have the RA, for example. So the RA now is equal to RS plus 2RP. And remember, the pitch must be equal. Finally, you have TA equal to TS plus 2TP. You need to memorize this. The reason is why most of the episode gear will not be given you the complete number of T. Like what you you asked me the equation number 17, if not mistaken, in the hoist, yeah. So that one is a part of the reverted gear. Okay. Okay, how do you define this one? You can check on my notes, yeah. So this one it's not very difficult, huh? Remember the equation of the PT. PT is equal to 2D, huh? Okay, we have a couple of minutes. Let me check whether you can complete or not here. So now I'm not going to do this one. I'm not going to do further because we have a couple of minutes. So what I intend to share with you now is here. But I intend to share this one, yeah. So there are two methods of solving the problem. One is by using tabulation. This one is the simplest, easiest, and easy to check whether you get wrong or right. Okay, but not many books will do this one. Will show you this one in details. Most books typically written by the European scholar, yeah, love to solve this one by using analyticals. This one is what you've been learned in dynamic as relative motion. What the relative motion? You have 3 gears just now, isn't it? So you have what? The gear of A, S, and P. So this one you will be connected. So you will use the what you call it, the relative velocity. So I'm going to share with you the tabulation method first before we meet the analysis. If I have ample of time, I'm going to share with you how the analysis or perhaps the formula method can be also used to solve the problem. Then you can compare the result and also the difficulties of these methods. Because in the exam or in any problem, they will use specifically method to solve these problems. Okay. So let me introduce the tabulation method first. Okay, this is the tabulation method. A bit more, yeah, a bit more. So the tabulation method here, if you remember what the video clip just now mentioned, to define find the gear ratio, you have two conditions, right? One will be hold or lock gear. Which gear you want to lock? Gear, you have to lock a gear that attached to planet or arm. Attached to planet or arm. The other one is you free the gear. Free the gear. But to do this, you need information. You cannot simply say you want to lock the gear, you want to free the gear. You need information. So what will be the information? So I'll meet you again, inshallah, in the next meeting tomorrow, yeah, at 8. So I'll be explaining to you all the parameter, all the theoretical, and then we go beyond that, do all the exercise. So any question before we end our class today? Anyone would like to ask? No?
Doctor,
Yes.
for the lock gear, which gear should we lock?
Okay. Okay. Bear in mind this one. The gear you want to lock is the gear that attached to arm or planets. Meaning to say that you can lock Annulus or you can lock Sun. Okay. Okay. The next question. Why you want to lock? Because the question asks you to do so. For example, yeah, the question say that find the gear ratio of the episode given by locking S1, for example. So you need to lock the S1. Okay. Am I answering the question now?
Yes, doctor. Yes, doctor. What about the gear to free, doctor?
But if the question doesn't mention anything about locking the gear, so you need to free all the gear. So how to go about it? We are going to look that one, inshallah, next mornings.
Okay, thank you, doctor.
Okay. Hope you enjoy my class. Hope even though you found that I keep changing my slide, I hope that not distract your your focus in my class. Yeah. So thank you, class. Thank you for having you in my class. So hope to see you tomorrow. So stay healthy and stay safe and do the assignment. So the next assignment will be the vehicle dynamics. Thank you. So I see you tomorrow. So with that, I end my session with Assalamualaikum warahmatullahi wabarakatuh and see you again.